All right, 8.4 notes, sum and difference formulas, page 9. So today we're going to find the exact measures of angles by adding or subtracting special angles. So these are all of the sum and difference formulas. I'm not going to go through and prove them with you, but just trust me, these are the formulas. You have to pay attention to how they're written. So some of it is kind of strange. It goes sine of angle A and then cosine of angle B plus cosine of angle A times the sine of angle B. But notice with cosine, when you're adding two angles, it goes cosine, cosine, and then this has a minus in between, which is opposite of what's in the parentheses, and then it goes sine, sine. So you have to pay attention. This one's sine and then cosine. This one is cosine, cosine, and then the signs might be flipped. So pay attention when you're using these formulas. So we're going to start with number 1. It says to find the exact value without using a calculator. So we could type in cosine 15 degrees and get a decimal, but this wants the exact value, and a decimal will never be exact. Notice 15 degrees is not a special angle. Our special angles are 30, 45, and 60, and then like the 90, 180, 270 as well. So how can we use those special numbers to make 15 degrees? Well, we could take the special angle of 45 degrees and subtract the special angle of 30 degrees, and notice that would be the same as the cosine of 15 degrees. So if we're going to do this, you have to use the subtracting cosine formula. So it's the second cosine formula that you're subtracting the two angles. So now we're going to do substitution. You have to show this step. So you're going to do the cosine of the first angle, which is 45 degrees. And then you have cosine of the second angle. It's not negative 30 degrees, it's just 30 degrees, okay? Then notice the formula says plus. Then we're going to do the sine of the first angle, 45 degrees, sine of the second angle, which is, again, 30 degrees, not negative 30, okay? So now I have to figure out what all of these are. And I can't do that without a picture. So let's draw a T. We're going to draw a triangle at 45 degrees. Notice that's less than 90, so it's going to be in quadrant 1. The angle's 45. The pattern for a 45, 45, 90 triangle are the legs are 1 and the hypotenuse is square root of 2. Going right is positive, up is positive. So I also am going to need a 30-degree picture. So that's still less than 90, so it's in quadrant 1. This time my angle is 30. It's a different pattern. Remember, opposite the 30 is 1. Opposite the 60 is the square root of 3. And then the hypotenuse is 2, whole number 2. And then right is positive, up is positive. So we're going to start filling in these ratios now. So I need the cosine of 45 degrees. So I'm up here. Cosine is cut, A over H. So I'm going to get 1 over the square root of 2. But I need to rationalize that. So 1 over the square root of 2 would rationalize, moving the root 2 on top, taking the number out of the bottom. It'll become root 2 over 2. For cosine of 30, cosine again is ca. I'm down here at 30 degrees. It's adjacent over hypotenuse, so that's root 3 over 2. Drop the plus sign. Now I'm doing the sine ratio of 45 degrees, so I'm back up here. Sine is so, O over H, so it's 1 over root 2. Which rationalizes to root 2 over 2. And then your sine of 30, back to 30, sine is so, O over H, so it's 1 over 2. So PEMDAS, you multiply these before you try to add them. So when we multiply square roots, they can have a different number inside when multiplying, just not when adding. So root 2 times root 3, that would make root 6, over 2 times 2 is 4, plus square root of 2 times 1, that's the square root of 2, over 2 times 2, which is 4. Hey, look, you have a common denominator, so we can add the tops. But notice the tops are a different number inside the square root. You can't add those together, so you have to keep those separate. So we're going to write this as root 6 plus root 2 all over the common denominator 4. And that is the exact value for the cosine of 15 degrees. All right, let's do that all over again. So how can I make 75 degrees using the 45, 30, 60, 90, 180 pattern? In this case, I'm going to do 45 plus the 30. That makes 75 degrees. So now I'm using the cosine ratio, but this time I'm adding the numbers. So here I am at the top, adding cosine angles. So it's the cosine of the first angle, 45, cosine of the second angle, 30. Then the formula is minus the sine of the first angle, which is 45, sine of the second angle, 30. Well, we already have a picture from part A of the 45 and 30 degree angles, so now it's just a matter of substitution. So you go ahead, finish this problem. All right, so your cosine ratio is 1 over root 2, which is root 2 over 2 when you rationalize. Cosine of 30 is root 3 over 2 minus sine is 1 over root 2, which is root 2 over 2. And then sine is O over H, so 1 over 2. And then you multiply them, and then you subtract. So the only difference between A and B is this now has a minus in between on the top. All right, moving on to C. Notice this time I have a sine function. So that means I'm going to use one of my sine ratios. And notice they already broke this apart for us. So we're doing the adding sine formula. That's the top sine formula. So following along, it's the sine of the first angle, 3 pi over 4, times the cosine of the second angle, pi over 2, plus, now you have cosine of the first angle, which is 3 pi over 4, times the sine of the second angle, pi over 2. So now I have to draw these pictures. 3 pi over 4, remember every 90 degrees is half a pi. So this is more than half a pi, less than a full pi. So it's more than half pi, less than a full pi, so it's over here. And then my denominator is 4, so my angle is pi over 4. This is a 45, 45, 90 triangle, so the legs are both 1, and the hypotenuse is the square root of 2. Going left is negative, up is positive, and the hypotenuse is always positive. I also have to draw a picture for pi over 2. Notice that's half a pi, so that's going to land right here at 90 degrees. So it's going left and right 0, but up 1, so the point is 0, 1. All right, so finding the sine ratio up here, sine is so, O over H, so it's 1 over root 2. Oh, I labeled my AO with the hypotenuse of 1. But sine ratio 3 pi over 4, so that's 1 over root 2, which is root 2 over 2. Doing cosine of this point here, cosine is chi, A over H, so it's 0 over 1, which is 0. Plus, you have the cosine of 3 pi over 4, so back up here, cosine is chi, A over H, so it's negative 1 over root 2. That's going to rationalize to a negative root 2 over 2. And then the sine of pi over 2, sine is so, O over H, so it's 1 over 1, which is 1. Multiply before you add, doing PEMDAS here. So this times 0 is just 0, plus negative root 2 over 2 times 1 is negative root 2 over 2. Adding that to 0, you get negative root 2 over 2. Alrighty, part D, you're subtracting angles with the sine ratio. So that's the second sine formula. So here we go, using the formula. It's the sine of the first angle, 5 pi over 6, times the cosine of the second angle, 5 pi over 3. Notice I'm not doing negative 5 pi over 3. That negative gets counted into this formula, so it's a positive there. So then we do minus. It's the cosine of the first angle, 5 pi over 6, and then sine of the second angle, 5 pi over 3. So we need two pictures. 5 pi over 6, that's more than half a pi, less than a full pi, so it's over here. The denominator is 6, so this would be pi over 6. This is equivalent to 30 degrees. So opposite the 30 is 1. Opposite the 60 is root 3. The hypotenuse is the whole number 2. Left is negative, up is positive, and the hypotenuse is always positive. So now I need to do 5 pi over 3. This can be rewritten as 1 2/3 pi. So it's more than half a pi, more than 1 pi, more than 1.5 pi, but it's less than a full 2 pi. So it's over here. The denominator is 3, so this is pi over 3. That's equivalent to 60 degrees, and opposite the 60 is root 3. Opposite the 30 is 1, and the hypotenuse is the whole number 2. Right is positive, down is negative, the hypotenuse is always positive. So now we can put in the ratios. So the sine ratio for 5 pi over 6, up here, sine is so, O over H, so that should be 1/2. The cosine of this triangle here, cosine is cut, A over H, so I'm getting 1/2. Drop the minus. Now we're doing the cosine ratio up here, so cosine is cut, A over H, so that's negative square root of 3 over 2. And then the sine ratio down here, sine is so, O over H, so that's negative square root of 3 over 2. So you multiply before you subtract, so 1 times 1 is 1, over 2 times 2 is 4, minus, you're doing a negative root 3 times a negative root 3, that'll become a positive root 9, over 2 times 2, which is 4. Notice the square root of 9 is 3. So I could write this as 1/4 minus 3/4 because the square root of 9 is 3. Notice you have a common denominator. I can subtract these fractions. So 1 minus 3 would be a negative 2 over our common denominator 4. And then I can reduce that fraction to get negative 1/2. All right, lots to take in there. All right, number 2, it says to write each expression as the sine, cosine, or tangent of an angle and then find the exact value. So this is like working backwards. They're giving you the plugged in numbers and you have to go backwards. So this formula goes cosine, cosine, plus sine, sine. Notice that's not this pattern, it's not this pattern, and it's not this one. Instead, it's this one down here. Cosine, cosine, plus sine, sine. So they're giving us the right side of this equation, which means I'm going to go to the left side of this equation. So it's going to become the cosine of the first angle 80 minus the second angle 20. So we're going from the right side now to the left side. Notice 80 minus 20 is 60, and that's a special angle that we can draw a picture for. So 60 is less than 90. We're going to draw a picture, angle 60 degrees. Opposite of 60 is the square root of 3. And then opposite the 30 is 1. And the hypotenuse is 2. Right is positive, up is positive. Your cosine ratio is cut, A over H. So you should be getting 1/2. All right, let's look at B. You have sine times the cosine minus the cosine times the sine. So the only one that has that pattern, sine, cosine, minus cosine, sine, is this formula. So that means you're using the left side over here. So you're doing the sine of the first angle minus the second angle. Go for it and tell me what the ratio is. Okay, so you should be getting the sine of 42 minus 12, which is 30 degrees. Opposite the 30 is 1, adjacent to root 3, hypotenuse 2. The sine ratio is so, O over H, so you should be getting 1/2. All right, for C, you have cosine, cosine, minus sine, sine. So cosine, cosine, minus sine, sine, that's this formula. You're going to go from the right side to the left side. So it's going to become cosine, and then you're adding the two angles. So I'm adding pi over 2 plus pi over 3. You need to get a common denominator. So I'm going to multiply this by 3 over 3 and this by 2 over 2. So this will become 3 pi over 6 plus 2 pi over 6, which makes 5 pi over 6. So then we can draw a picture. This is more than half a pi, but less than a full pi, so it's over here. The denominator is 6, so this is pi over 6. That's equivalent to 30 degrees, so opposite is 1, adjacent is root 3, the hypotenuse is 2, left is negative, up is positive, and the hypotenuse is always positive. So from this photo, what is the cosine of 5 pi over 6? All right, so cosinus cut a over h, so you should be getting negative root 3 over 2. All right, part D, these have the word tangent in there, so it's the tangent formulas. We have a adding on top and a subtracting on the bottom, so that would be the top formula. So we're going from the right side to the left side. So it's the tangent of adding the two angles. So we're adding the 10 and the 35, which is going to make 45 degrees. We have to find the tangent ratio. 45 is less than 90. It's my reference angle is 45. The legs are 1. The hypotenuse is root 2. Tangent ratio. Tangent is TOA, O over A. So 1 over 1 is 1. All right, number 3, we're supposed to verify the identity. So we're going to prove that the sine of x plus pi over 2 actually equals the cosine of x. Kind of a cool little proof here. So it's the sine formula, and we're adding two angles. So we're going to be doing the first formula here, and we're going to be simplifying the left side. Remember, always say which side you're going to work on. So it goes sine of the first angle, x, cosine of the second angle, pi over 2, plus cosine of the first angle, x, sine of the second angle, pi over 2. So notice you can't draw a picture for the sine of x or the cosine of x. That's not going to work. But I can draw a picture for pi over 2. Pi over 2 is half a pi, so it's over here at 0, 1, where this is a AO and a hypotenuse of 1. So we can't plug in x. The sine of x is going to drop down. But the cosine of pi over 2, cosine is cut, A over h. So it's 0 over 1, which is 0. Plus, dropping down the cosine of x. Now we need the sine of pi over 2. Sine is so, O over h, so it's 1 over 1, which is 1. Then we simplify. You get sine of x times 0, which is 0, plus cosine of x times 1 is cosine of x. And then 0 plus the cosine of x is the cosine of x. Hey, look, it matches the right side. I'm done. Let's do it again. Put a little star next to this one. This one may be on a test. So as we're looking at this problem, notice you're subtracting two angles at the top. So that's the subtracting cosine formula. This is going to be this one down here, subtracting angles. And you may have trouble writing the alpha and beta in Greek, but you can just use the letters A and B. It's the same thing in English, right? So we are going to write this top part is going to be replaced with the right side formula. So it's going to become cosine A, cosine B, plus sine of A, sine of B. And then this is all over sine A, cosine B. These are being multiplied. Notice both of these terms are being divided. So I'm going to break them apart. You can consider this the heart method if you want. Some people might know what that is. So we're dividing the first term by sine A, cosine B. So that'll be cosine A, cosine B over sine A, cosine B. Plus, now I'm dividing the second term by this. So it's going to become sine A, sine B, also being divided by sine A, cosine B. You can only do this when the plus is on the top of the fraction. If it's on the bottom of the fraction, it doesn't work. You can't split them up if that's the case. So notice, hey, look, these both have a cosine B. Those are going to cancel. Now I have cosine A over sine A. And if you recall, cosine over sine is cotangent. And then we have plus sine B over cosine B because the sine A is canceled. And then cosine and sine makes cotangent of A. And sine over cosine is the tangent for angle B. Hey, look, that's the right side. I'm done. All right, for C, we're going to work on the left side. You have cosine of A plus B, so you're adding the cosine formula, so that's the first one. It's going to be replaced with the one over here. So it goes cosine A, cosine B, minus the sine of A, sine of B. So that's this part. And then I'm adding the subtracting cosine formula, which is this one. So it's going to go cosine A, cosine B, plus sine A, sine B. So if you notice, these are like terms. I have a cosine A, cosine B, and a cosine A, cosine B that makes two cosine A, cosine Bs. And then notice these are like terms. You have a negative sine A sine B and a positive sine A sine B. Since one's a negative, one's a positive, they cancel each other. Hey, look, that's the right side. I'm done.